Okay, so Unit 2 starting from energetics. This is the first chapter in your specification. I would be revising all the chapters, inshallah, but I would summarize basically, okay? The important points or some important concepts. Starting from energetics, hopefully you know there are two types of reaction, exo and endo. Exothermic means that energy is being released, and endo means energy is being absorbed. Delta H is negative for exothermic, and delta H is positive for endothermic, like enthalpy change. So you will see that this is the graph for exothermic reaction in which you can see this is activation energy. This is what? This is activation energy. So activation energy is lower for exothermic and activation energy would be higher for endothermic. So you can see the difference. Like the length of activation energy is higher for endothermic and the length of activation energy is lower for exothermic. Endothermic reaction starts basically they require higher energy as compared to exothermic system. Okay, and also remember activation energy is always positive. You will always see that the direction of an arrow is upward always because activation energy is positive. But of course delta H when the arrow is upward so means that it is positive like endothermic, and when it is downward so you can say the delta H is negative means that the reaction is exothermic. Okay, and then we have to discuss some processes, some, let you can say, like first of all enthalpy change of formation. When 1 mole of a compound is formed from its elements in their standard states under standard condition, let's suppose this is H2O liquid and I have to form H2O, so I need 1 mole of a compound is formed from its elements in their standard states. So hydrogen in the form of gas, because the standard form of hydrogen is a gas, and this is oxygen. You can see in water we have only one oxygen, so half O2, because O2 is always diatomic. Okay, O2 is always diatomic. So this is the equation for the enthalpy change of formation. I cannot say that this is exo or endo. It's not fixed. It depends on the values what the examiner has given you. Sometime it may be exothermic and sometime it may be endothermic. Depends. Okay, so we cannot say that always exo or always endo. It's not fixed. And if you can see combustion, yeah, for combustion we can say that. Okay, for combustion we can say that it's always exothermic because it's energy released, always exo. When 1 mole of a substance is burned in an excess of oxygen to form respective oxides under standard condition, like means that the oxide of carbon is carbon dioxide and the oxide of hydrogen is water. Respective oxide, let's suppose in the reactant side if you have CS2, so the oxide of carbon would be carbon dioxide and oxide of sulfur would be sulfur dioxide. Okay, like people think that always we would be having carbon dioxide in water. It's not fixed. If you have a hydrocarbon then that's true, but if you have other than carbon and hydrogen, so remember the like you can say respective oxide would be forming. Like oxide of sulfur is sulfur dioxide. Okay, and it's always exothermic. So one mole of a substance is burned. Whenever you are going to balance this equation, whenever you are going to balance this equation, so remember, you cannot write any number over there. Same goes with the formation. When you are going to balance this equation, so you are not supposed to write any number in the product side. 1 mole of a compound is formed. One. And same goes with this one. You can change the numbers over there only. This is fixed, okay? Because according to the definition, you must have 1 mole of a compound, and according to the definition, you must have 1 mole of a substance that is burned in an excess of oxygen, okay? Then we have neutralization, always exothermic, okay? Only the formation is like both, maybe exo, maybe endo. Otherwise, rest of the processes are always, like some processes are always endothermic and some are always exothermic. So neutralization is always exothermic. So what is this? According to the definition, enthalpy change when 1 mole of acid reacts with an alkali to form 1 mole of water. You can take any of the acid and bases, okay? But generally, mostly we take HCl and NaOH, H2SO4 and NaOH. But it's a concept, of course, if you are going to write an ionic equation for acid and bases. So you will see that H positive aqueous would be reacting with OH minus aqueous, would be forming water. H plus is coming from acid and OH minus is coming from alkali, and they are going to form water. Since this is neutralization, so it would be always exothermic, okay? And this is a calculated value whenever you are having any acid or bases, a strong acid and a strong base. So this much energy is released, that is minus 57 kilojoules per mole. Okay, this is already calculated if you have a strong acid and if you have a strong base. Okay, and then you would be calculating how to measure standard enthalpy change of neutralization and standard enthalpy change of combustion. So, we have a relation that is Q is equal to mc delta T. What is Q? It's enthalpy change. This is the mass. C is specific heat capacity and delta T, temperature. So, this is the question. Okay. Like the volume of HCl is 25 cm cube, volume of NaOH is 25 cm cubed, initial temperature is this, final temperature is this. What you have to do, you have to take total mass of total mass of the solution. Since we know that we have taken a volume in cm cube, so the density of water is 1. So density is equal to mass upon volume. So volume multiplied by 1 is equal to V1 is equal to V, and then this is the mass. So mass is equal to volume because the density of water is 1. So I'm going to take 50 centimeter cube as a 50 grams that I'm going to put in this equation, and I would be getting Q, and the answer would be always in negative because this is neutralization. Whether your calculator is not giving you negative, but you have to write down the negative charge since we know that this is exothermic reaction. So always the answer would be in negative. So that's why it's negative 1463 joules. And sometime examiner would be asking in kilojoules. So you are supposed to divide it by 1000. So the answer would be in kilojoules. Simple. And then same goes with this. 50 cm cube of this one, 50 cm cube of this one to form salt and water. Calculate Q. Again, I'm going to do the same thing. Total volume 50 plus 50, that is 100 grams. C is 4.18. Delta T is this. Final minus initial temperature. And this is the answer 5225 joules. Since you know that we are supposed to find out the value in kilojoules per mole, in kilojoules per mole. So this is the energy released by this 1 moles. How much? I'm going to calculate the moles first. Concentration times volume. Concentration is 2. Volume is 50 upon 1000. It would be zero point 0.1 mole. So zero point 0.1 mole releases this much energy. How much energy would be released if I have 1 mole? Because you have seen that all the processes are per mole, kilojoule per mole. Whether you are going to do formation, whether you are going to do combustion, whether you are going to do neutralization, any process would be in terms of kilojoules per mole. So you have to do this step. This is the mandatory step, final step. After finding the value, that is your Q, then you have to calculate the moles first. Of course, in that question, the data would be given to you. Okay. And then afterwards, then you can relate like this much energy is released if we have this much mole. So how much energy would be released if we have 1 mole? So that would be your answer. Simple. And same goes with the combustion. Same goes with the combustion. Again, the same thing. I have taken volume of water, that is 500 centimeter cube, and this is initial temperature of water, then final, then mass of the fuel before combustion, after combustion. Difference is 5 grams. Most of the people ask, sir, which mass am I supposed to take whenever I'm going to apply this formula? So remember, always you are supposed to take volume of water, not the mass of the fuel. Remember, because when you are going to apply heat, so of course the temperature of the water is going to increase, so you would be taking the mass of water. So I did the same thing. 500 grams, C is a specific heat temperature, then I got 14.63 kilojoules. Again, I have to find per mole. So mass of ethanol is 5 upon 46. Like mole of ethanol, this is the mass divided by the molecular mass, that is 46. The formula for ethanol is C2H5OH. Okay, so this is the mole of ethanol, and then this much mole releases this much energy. So how much energy would be released if I have 1 mole? Okay, so that would be your option. That would be your answer. Kilojoules per mole. Always remember kilojoules, whether you are calculating neutralization, whether you are calculating combustion, the answer would be always in kilojoules per mole. So in this chapter, this is the main thing. This is the main target. Okay. So this is of like more marks. Let's suppose this is of 4 marks or 5 marks. So depends. Along with the definition of any process, so it would be coming like 6 to 7 marks. So it's more than enough. Okay. And then secondly, Hess's law. You will see some questions related to this. So we have two methods to do these type of questions. If you are going to have this question in MCQ, so you can do it directly. And if this question comes in the theory portion, so of course, examiner would be asking to draw the Hess cycle. So then you have to draw. But if it is in MCQ, so you can do it directly. You will see two type of questions, formation and combustion. If you can see the question related to the formation, so you can directly apply the formula, that is for formation is equal to delta H is equal to Pakistan Railway, product minus reactant. And if you are going to calculate combustion, so you can apply the formula, that is reactant minus product. Okay. So, but if they are asking to draw the Hess cycle, so remember, for the formation, reactant, then product, and then elements, always the arrow would be upward for the formation process, and always the arrow would be downward for the combustion process. Remember. And afterwards, this is direct route and this is indirect route. What's the definition of Hess's law? Direct route is equal to indirect route. Of course, they would be releasing the same energy. So direct route is equal to indirect route. Again, the same thing. Direct route is equal to indirect route. But what's the difference? The arrows are downward, downward, upward, upward. Let's do some questions to get an idea that what we like how we would be dealing with these type of questions. If you can see this one, uh, this is the equation, and of course, they are saying it's enthalpy change of formation. Of course, this question is from formation. So then how we can solve this question? And most of the people ask how much arrow we are supposed to draw. So number of values are equal to number of arrows. If you are given two values, so you would be making two arrows. And if you are given three values, you would be making three arrows. If you are given only one value, you would be making only one arrow. So it's quite clear. Number of values given are equal to the number of arrows. So that's the reason I have drawn two arrows only, simple. And then And then formation of HCl, that is minus 92. As the coefficient is 4, I am going to multiply this by 4. And the formation for water is minus 242. Since the coefficient is 2, I am going to multiply this by 2. Okay. This is direct route. This is indirect route. I am going downward. I am going downward. And this arrow is going upward. So this value is just opposite to me. I will change the sign of this value. So plus 92 multiplied by 4, I'm going upward. The arrow is also going upward. I'm not supposed to change the sign of this value. So just you can solve it. So you would be getting the answer. Simple. That's it for the Hess's law for the formation question. Only. Like you can see this, it's related to combustion. Number of values are equal to number of arrows. I have drawn 3 arrows because there are 3 values. Downward arrow because the combustion question. This is indirect route. This is the direct route. I am going downward. This arrow is also going downward. This arrow is also going downward. I'm not supposed to change the sign of this value. They are the same. Negative 283, negative 286. Since the coefficient is 2, you are supposed to multiply this by 2. But I am going upward. The arrow is going downward. I'm supposed to change the sign of this value. That is minus plus 726. You can solve it. You would be getting the answer. It's very simple. It's very simple. Okay. Then uh okay. So then sometime he would be asking standard enthalpy change of reaction. Reaction means that it's a simple one. It's not formation, it's not combustion, it's not neutralization. So what is this? Standard enthalpy change when occurs when equation quantities of materials react under standard condition. Means that there is no such condition, there is no such criteria. If you are going to balance it, it must be one, it must be one. No, but you need to write down the symbols, of course. But there is no such criteria. Like in the formation, we had to balance this. But in the product side, there must be one. And if you're going to think about the combustion one, you are supposed to balance it. But in the reactant side, you must have one. If you are going to do neutralization, always 1 mole of water is produced. But in this, there is no such criteria. It's simple one. Okay, it's very simple. So this is all about the energetics. Okay. So remember, in this chapter, you must focus on Q is equal to MC delta T questions. You must solve 2025 paper, January 2025 paper. Okay. Or you must know the definitions. Which one is exothermic? Which one is endothermic? Which one is both? Okay. Which one is both? And how to solve Hess's law, like the formation question and also the combustion question. Okay. And then afterwards, intermolecular force of attraction. Intermolecular force, there are 3 types of intermolecular force according to your specification. Number one, we have London force, that is also known as dispersion force. That is also known as van der Waals force. That is also known as instantaneous dipole and induced dipole force. One force, multiple names. So intermolecular, between the molecule. Like let's suppose this is water. What is this? You will say this is covalent bond. Covalent bond, covalent bond, covalent bond, covalent bond. So the force of attraction between the two molecules represented by dotted lines is called intermolecular force. Intermolecular force. That's it. So when you are going to boil water, what would be the product? Some people say, sir, we would be having hydrogen gas and oxygen gas. How is that possible? You mean that this bond is going to break down if you're going to boil it? So means the covalent bond is going to break down? No. only the intermolecular force gets weakened. Only the intermolecular force gets weakened. So that's why intermolecular forces are something else, and covalent bond, ionic bond, dative bond, metallic bond, they are something else. There is a huge difference between the intermolecular force and the normal bonding. Okay, it's the physical bonding. It's not a chemical bonding. It's a physical bonding. So we have three types of intermolecular forces. And before going to do that, you must know IMF are absent in these structures. So you're not supposed to just keep looking in these molecule. Diamond is going to have intermolecular force. No, silica doesn't have intermolecular force. Ionic compound doesn't have intermolecular force. Metallic bond doesn't have intermolecular force. So you are not supposed to waste your time. Okay. And starting from the permanent dipole, this force is always present between the polar molecule. Polar molecule. How can you identify whether the molecule is polar or non-polar? Of course, there is a different element. H is different, Cl is different with different electronegativities. Electronegativity for chlorine is higher, electronegativity for hydrogen is lower. As a result, as you know that electronegativity is higher for chlorine, it would be having partial negative charge, it would be having partial positive charge. So the molecule becomes polar, and this is permanent dipole. You will never see that after 5 minutes, after 10 minutes, after a day, after a week, after a year, the charges are going to eliminate. No, they are always fixed because this is a permanent dipole. Okay. And of course, once they got positive and negative charge, so they would be starting to attract other molecule as well. As a result, you will see HCl molecule would be attracted by another HCl molecule. So that is known as permanent dipole. That is known as permanent dipole. So in a polar molecule, there is unequal distribution of electron. Chlorine is going to have more electrons. That's why it's partial negative. Hydrogen is going to have less number of electrons. That's why it's partial positive. So always there would be an equal distribution of electron in a polar molecule, whether you have HCl, whether you have HBr, whether you have ammonia, whether you have water, whether you have C2H5OH, ethanol, methanol, propanol, ethanoic acid, butanoic acid, any polar molecule. If I ask, if I ask what type of IMF exists in methanol, since you know methanol is polar, so directly straight away you are supposed to tell me permanent dipole, permanent dipole. Always remember for a polar molecule, permanent dipole, PD force, PD force directly. And if you have a non-polar one, if you have a non-polar one, so then you can say temporary dipole, induced dipole, or you can say London force, or you can say dispersion force. How can we identify whether it's polar or non-polar? All diatomic elements H2, Cl2, Br2, I2, N2, O2, F2, they are all non-polar. Along with that, all hydrocarbons, methane, ethane, propane, butane, ethene, propene, butene, pentene, hexene, all hydrocarbons and all the diatomic elements are non-polar. So in that, there would be London force, and it depends on two factors, number of electrons and surface area. Like I'm asking, methane is high melting point or ethane? Of course, you will say ethane. More electrons, strong London force, higher melting point. Less electron, weak London force, lower melting point. Helium and neon, which one is having high melting point? Of course, neon. Why? More electron, strong intermolecular force, high melting point. Helium, less electron, weak IMF, low melting point. That's it. It's very simple. Okay. And have you ever seen this molecule? It's a long chain that is called, you can say that 1, 2, 3, 4, 5, 6, 7, 8. Of course, the surface area is higher, but I'm going to make this molecule just like that. So the surface area becomes lower. It is occupying less space. It is occupying more space. Surface area is directly proportional to the London force. When the surface area is higher, so the London force is higher. So it's quite clear. It depends on the number of electrons and also the surface area. Okay. And then we have hydrogen bonding. Hydrogen bonding, of course, it's the strongest one among all the intermolecular forces. Like ionic bonding was the king among all the bondings. Covalent, uh, dative, metallic. Okay. Ionic bonding was the king. Same goes with this. We have three types of IMF. So hydrogen bonding is the strongest among all the intermolecular forces. So hydrogen bond is formed between hydrogen and fluorine, oxygen and nitrogen. HF, yes, there is hydrogen bonding. HCl, no. HBr, no. HI, no. Ammonia, yes, hydrogen bonding. Because NOF, bond between hydrogen and fluorine, oxygen and nitrogen, they are highly electronegative elements. They are highly electronegative elements. Okay. So if there is hydrogen bonding, let's say, so is there any difference in the physical properties? Yes. When there is hydrogen bonding, so the boiling point is higher, melting point is higher, solubility is higher. I'm asking, I'm asking, carboxylic acids are more soluble or alcohols are more soluble? Like let's suppose this is methanol. This is methanol. This is ethanoic acid. This is ethanol. This is ethanoic acid. Carbons are same. Which one is more soluble? I will say this is more soluble. You know why? It has two oxygens. It's going to make two hydrogen bonds. It's going to make only one hydrogen bond. So when the number of hydrogen bond increases, so remember, when the number of hydrogen bond increases, so the solubility increases and also the melting and boiling point increases. Okay, also the melting and boiling point increases. Okay, so and of course alcohols are more soluble, they are miscible in water. You know why? Because they are going to make hydrogen bond with water, so that's the reason it has a higher solubility. It has a higher solubility. Okay, so intermolecular force, you will see a lot of questions related to this, but that would be very easy. That would be very easy. Sometime they have going to have a comparison between the two molecule. It's going to have higher boiling point. This is lower boiling point. This is polar. This is non-polar. London force exists between these molecule. Permanent dipole exists between these two molecules, and hydrogen bond exists between the following. So you will see questions in MCQ as well, and also in the theoretical portion. It's quite easy according to the examiner point of view, according to the your paper. So this is quite easy chapter as compared to energetics, because uh, it's clear cut chapter. Like this is polar, okay, permanent dipole. This is non-polar, okay, means that London force. And then if it has a London force, then you have to do a comparison. Then you have to do a comparison. Which one is going to have high boiling point? Which one is going to have low boiling point? Then you will be doing a comparison. Of course, I told you. Of course, I told you that it depends on two factors. Number one, electrons, and number two, surface area. More electrons, strong intermolecular force. So boiling point would be higher, okay? And less electrons, weak London force. So the melting and boiling point would be lower. It's very simple, okay? And same goes with the surface area. Basically, they are directly proportional to the intermolecular force of attraction, okay? And then next thing is redox. Redox, the term red and ox means that reduction and oxidation consist of the two processes, red and ox, reduction and oxidation simultaneously. Simultaneously, the reaction in which oxidation and reduction can take place simultaneously. What is oxidation? Loss of electron, loss of hydrogen, gain of oxygen, increase in charge. What is reduction? Gain of electron, gain of hydrogen, loss of oxygen, decrease in charge. So if you know the oxidation, you will know the reduction. Vice versa of oxidation is reduction. Okay. Then you have to find out the chart. This is very important. This is very important. Like this chapter is quite small, but you will see a lot of questions. Sometimes they would be asking to find out the charge. Sometimes they would be asking to balance redox equation, of course. Okay. So let's suppose in KMnO4, of course, K is in group 1, so this is plus 1. Oxygen is minus 2. You have 4 oxygens. So I have to find out the charge of Mn. That would be plus 7. Simple. So when you are going to find out the charge of manganese, you must know the charge of oxygen. You must know the charge of potassium. You must know the charge of oxygen. And you must know the charge for potassium. That is in group 1. So means that this would be plus 1. Same goes with this. K2Cr2O7. K is plus 1, oxygen is minus 2. So I can find out the charge of chromium, that would be plus 6. Same goes with H2SO4. I know the charge of hydrogen. I know the charge of oxygen. I can find out the charge of sulfur, that is plus 6. If you are having any difficulty, then do let me know, okay? I would be available after the class as well. And then KClO2. Then KClO2. K is plus 1, O is minus 2. So Cl is plus 3. Same goes with H2O2. Oxygen is minus 1. And that's it. And for the ions, it's ammonium, NH4 plus. So I'm going to is equal to plus 1. Like if you can see these things, I was taking is equal to 0, 0, 0, 0, 0, 0, 0. But right now there is a charge. I'm not supposed to equal to 0. It's equal to plus 1. Is equal to the charge on that ion. The charge is minus, so is equal to minus 1. The charge is minus 2 is equal to minus 2. So then you can find out the charge of sulfur. Same goes with nitrogen, hydrogen, Mn, sulfur, again the nitrogen. So that's the difference between the normal molecule and the ion. Okay. I would be sending the notes as well. So do not copy this. Just focus on this. Okay. And how to balance equation? How to balance a redox equation. Okay. So let's suppose these are the rules to balance redox equation. First of all, you have to split equation into two halves. Then you have to balance metals. Then you have to balance non-metals except hydrogen and oxygen. Then balance oxygen by H2O. Then balance hydrogen by H plus. And then balance the charge by adding electrons. And then you have to add two half equations after cancelling electrons. Let's apply these points, these rules to the specific equation. This was the equation. Okay. This was the equation. So I have split this equation into two halves. MnO4 minus changes into Mn2 plus. Okay. And then Fe2 plus is going to change into Fe3 plus. So I have done this. I have split this equation into two halves. And then how many oxygens? 4. I'm going to write 4 water molecule. After writing 4 water, how much hydrogens we have? 4 into 2 is 8. Hydrogen is balanced by H plus. According to the rule, I have written 8H positive. Then I'm going to balance the charge. This is plus 2. This is 0. This is minus 1. This is plus 8. Plus 8 minus 1 is plus 7. So in the product side, how much the charge? Plus 2. So it should be balanced. It should be balanced. I'm going to add 5 electrons. When you are adding 5 electrons, means that you are doing just like that. 7 minus 5, that is equal to plus 2. Plus 2. They are the same. Okay. And Fe plus 2 into Fe plus 3. How much the charge? Plus 2. This is plus 3. I'm writing 1 electron. It would be 3 minus 1. That is equal to plus 2. Okay. How many electrons we have in equation 1? 5. So I'm going to add these equations together. Electrons must be cancelled. I'm going to multiply the second equation by 5. You know why? Because after multiplication, the electrons would be the same and I can cancel electrons. And this is your overall equation. This is your overall equation. Again, if you are unable to balance it, so just do let me know. Just do let me know, then I would be telling you then again. Okay. Uh, I have I have multiple recordings of the same topic, so you can see over there as well. Okay. A lot of. I have solved one by one each equation. This one, then this one. So you can see over there. It's very easy topic. And then, of course, oxidizing agent, then reducing agent. In the same equation, you have to identify which one is oxidizing agent and which one is reducing agent. Like let's suppose MnO4 minus changes into Mn2 plus. Loss of oxygen or decrease in charge. It's going from +7 to +2. Reduction is taking place. Decrease in charge. Reduction is taking place. When something reduces itself, is an oxidizing agent. Fe2 plus 2 Fe3 plus charge is going to increase. When charge increases, so means that it is oxidized. And when something oxidizes itself is a reducing agent. It's quite simple. It's very simple. So whenever you are going to identify oxidizing agent and a reducing agent, so you must know where is oxidation taking place and where is reduction taking place. Okay. And then we have disproportionation reaction. You know what is disproportionation? In this equation, in this reaction, in this process, same substance is oxidized and the same substance is reduced. Like this is famous equation. Chlorine is reacting with NaOH to form NaCl and NaClO3 and water. So it's changing from 0 to -1, means it's gaining electron, and 0 to +5. +5 means it has loss of electron. It is a loss of electron. So this is oxidation. Same substance is oxidized. At the same time, the same substance is reduced. So these type of reactions are known as disproportionation reaction. Disproportionation reaction. Okay. And then, and then uh, group chemistry, I think so, according to my point of view, that would be very important. And a lot of things are going to come from this group chemistry, especially the trends, like the atomic radius, like the boiling temperature, melting temperature, ionization energy, and also the thermal stability. Mark my point. Okay. So let's talk about first the trends. First of all, atomic radius. You will see in the marking scheme, they are sometimes use the word atomic or ionic radii. Sometime atomic radii and sometime ionic radii. Okay. So I would be telling you whenever you are supposed to use atomic radius and whenever you are supposed to use ionic radius. Okay. So they are the same thing, of course, or you are not supposed to use the term atomic size. Atomic size, no. Size or radius, yep, we know that they are the same thing, but examiners suggest that you are supposed to use the term radius, not the size. Remember, this is important to know. Sir, I did the whole paper. Okay, you did the whole paper. So when the result come, so they get B. Why? Sir, I have to recheck my paper. I did the whole paper. So why this is so? You did the whole paper. So, like, have you done your paper according to the marking scheme? Have you ever used the important terms according to the marking scheme, according to the examiner report? If yes, then you would be getting the mark. You would not be getting the mark, just you are keep writing, you're going to like fill all the lines, all the paragraphs. No, it's not like that. You must use the important terms. So that's why I'm saying atomic radius, why it increases, whether I'm talking about group 1, whether I'm talking about group 2. Atomic radius increases down the group. Why? Because number of proton increases, total number of shell increases, so the shielding increases. As a result, I can say the size increases. This is lithium. It has only 2 shells. This is sodium. It has three shells. Okay, it has three shells. Of course, the size of sodium would be higher. Yeah, you can ask, sir, why there are three shells in sodium? Because the proton number is higher. The proton number is higher, and when you would be having more electrons, so there would be more repulsion. There would be more repulsion, and when there would be more repulsion, so the size would be higher. Okay, and same goes with group 1, same goes with group 2. I'm talking about metals specifically. Okay, and then what about ionization energy? Ionization energy is inversely proportional to the atomic radius. Remember, ionization energy is inversely proportional to the atomic radius. When the radius is higher, so easy to remove electron. When the radius is lower, difficult to remove electron. Of course, common. Why? Why? This is the main question. Let's suppose it has a smaller size, it has a smaller radius. So electron is closer to the nucleus, strong attraction, cannot be removed easily. More energy required, high ionization energy. That's it. The size is higher. Electron is far away from the nucleus. When electron is far away, less attraction, weak attraction. Electron can be removed easily. Less energy needed. So it has lower ionization energy. That's it. That's the connection between the ionization energy and the atomic radius. Okay, are you getting my point? And then uh, ionization energy for group 2 is higher. You know why? Because the size of group 2 is lower. Because the size of group 2 is lower. When the size of group 2 is lower, so of course it would be having stronger attraction. It would be having a stronger attraction between the nucleus and outer shell. So more energy is needed to remove electron. That's why I am saying according to the trend when we go across the period. If you are thinking why the size of group 2 is lower, why the size of group 2? So let me tell you, let's suppose I have sodium and magnesium. Okay, so need your attention. This is 11, this is 12. So first shell has 2 electrons, and then second shell has 8 electrons, and the third shell has 1 electron. Okay, so same structure for magnesium. It has 2 outer electrons. Okay, since you know that both has 3 shells, sodium is in group 1, magnesium is in group 2. So inner electrons are same. When the inner electrons are same, so the shielding is same. Like that. When the inner, what is shielding effect? What is shielding effect? Repulsion between inner electrons. Am I right? Repulsion between inner electrons. Repulsion between inner electrons. When the inner electrons are same, so when the inner electrons are same, so the shielding would be the same. I am going to remove the inner electrons for simplicity. I'm going to remove inner electrons for simplicity. How many protons it has? 11 protons and 12 protons. Now I'm asking about attraction. Now I'm asking about attraction. So, 2 electrons versus 12 protons. 1 electron versus 11 proton. Which attraction is higher? You will say this one. Yeah, due to the strong attraction, the size of magnesium is lower. The size of magnesium is lower. That's why I was saying that the size of group 2 is lower and the size of group 1 is higher. The size of group 2 is lower, so the ionization energy is higher automatically. Of course, more energy would be needed to remove electron because the size is lower, the size is smaller. Okay? And these are some important exceptions. Phosphorus and sulfur. across the period size decreases, so the ionization energy should increase. So what about phosphorus and sulfur? According to the theoretical concept, the ionization energy of sulfur should be higher and the ionization energy for phosphorus should be lower. But this is but the actual thing is something different. Like sulfur is going to have lower ionization and it should have higher. You know why? If you are going to write electronic configuration, so you will see that it's ending on 3p4. 3p4, partially filled. You can see spin pair repulsion. You can see spin pair repulsion. Electrons are going to repel each other. Electrons are going to repel each other. So, which makes it unstable. So, less energy is required to remove electron. But if you can see phosphorus, it's ending on 3p3, which is half filled. Half filled is more stable. There is no spin pair repulsion. So this is more stable. More energy would be required to remove electron. That's why I am saying that the ionization energy of sulfur is lower. These are four exceptions that you need to know. These are four exceptions that you need to know. Okay. And then reactivity. Metal has to lose electron. Metal has to lose electron. If metal is losing electron easily, so that's more reactive metal. But if the metal is not going to lose its electron easily, so the metal is less reactive. So it's all about how ease they are going to lose or gain. They are going to lose electron. Okay. So of course, group one, the size of group one is higher. If the size is higher, so outer electron would be far away from the nucleus, less attracted, loosely attracted. It can remove its outer electron easily. So group 1 elements are more reactive. And what about group 2? Of course, the size is lower. Outer electron is near to the nucleus. More attraction, strong attraction. So it cannot lose its electron easily. So group 2 metals are less reactive. So what if I'm asking as we go down the group, whether you are going down the group in group 1 and whether you are going in group 2? Reactivity increases. Why? Because the size increases. So easy to lose electron. So the reactivity of metal increases. It's very simple. Very simple. Okay. And then uh okay. Yeah, melting and boiling point. Of course, they are metals. They are going to have metallic bonding. Of course, they are metals. They are going to have metallic bonding. Okay, they are going to have metallic bonding, right? They are going to have metallic bonding. So, what is metal? What is metallic bonding? Electrostatic force of attraction between the cation and C of delocalized electron. Electrostatic force of attraction between the cation and C of delocalized electrons. Okay, so as you go down the group, the size of cation increases. Of course, lithium is smaller, but potassium is higher in size. So the size of cation increases, attraction decreases, less energy is needed. Less energy is needed to melt or boil. You know why? When we go down the group, size of cation increases. So for the last one, that is francium, the size of cation would be just like that. So its attraction towards the electron is very weak. Less energy would be needed to melt or boil the substance. That's why I'm saying when we go down the group, melting and boiling point increases. Melting and boiling point increases. Remember, okay? So for both, I'm talking about for both groups. Remember, I'm talking about for both groups, group 1 and group 2. Reactivity increases, melting boiling point decreases, atomic radius increases. Okay, I will send you the notes. And okay. Yep. Of course, density also increases. You know that. Density is equal to mass upon volume. They are inversely proportional, they are directly proportional. So interestingly, down the group both increases. Volume also increases, mass also increases. So then what can I say? Like I should look at the mass and I should look at the volume. So now the thing is that which one is dominant? Which one increases more? Of course, mass increases more. Like if you remember, there are two shells in lithium, three in sodium, four in potassium, four, then five, then six, then they are increasing gradually. Volume increases gradually. And what about the mass? It increases drastically. What is the mass of lithium? You will say 7. What is the mass of sodium? 23. What is the mass of potassium? 39. Since the mass increases more, this is dominant. We can say that mass is directly proportional to the density. That's why density increases. Okay. And then let's talk about the chemical property. First of all, reaction with oxygen. Of course, they would react with oxygen. Beryllium would not react with oxygen since the activation energy for beryllium is very high. All the metals would react with oxygen and they would be forming their respective oxide. Magnesium oxide, same goes with sodium oxide, potassium oxide, rubidium oxide. I'm talking about both, group 1 and group 2 both, okay? And then reaction of metal oxide with water, they would be forming hydroxides. When you are going to react metal oxide with water, so they are forming hydroxide. Okay, hydroxide. So what should I write as a state symbol? Liquid or aqueous? Liquid or aqueous? You know, it depends on the solubility. You know that the solubility of hydroxide increases down the group. So it's insoluble, it's solid, but it's aqueous. You must know the solubility trend. You must know the solubility trend, okay? I'm talking about hydroxide especially. What would you observe? Of course, metal disappear. All are solid, 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 solid. When you would be reacting, the solid would disappear. And hydrogen gas is produced. So you will see bubbles, effervescence, and solution becomes cloudy. You know why solution becomes cloudy? Let's suppose this is insoluble. So you will see the white precipitate. So you will see the white precipitate. That's why I'm saying the solution becomes cloudy. Okay. The solution will not become cloudy if you are going to have barium hydroxide. You know, it's completely soluble. So you will see a clear solution. Okay. And reaction of metal with hot water. Okay. When you are going to react with hot water, so the oxide would be produced and along with that hydrogen gas. Okay. And then, of course, metal oxides are basic in nature. They are metal oxides, they are base, so they can react with acid and they would be forming salt and water. They can form salt and water, acid base reaction. This is neutralization. All metal oxides are basic and all non metal oxides are acidic. All metal oxides are basic in nature. So they would react with HCl. Okay, they would be forming salt and water, simple. And purely metals can also react with hydrochloric acid. They would be forming salt and hydrogen gas. They would be forming salt and hydrogen gas. Same goes with group 1. So straight away you are supposed to memorize these reactions. Acid can be H2SO4, acid can be HCl, acid can be HNO3, acid can be any. Acid can be any. Then we have the very important concept that is called the thermal stability. What is thermal stability? Thermal stability means that he would be asking about the two compounds, thermal stability of carbonate and also the thermal stability of nitrate. Okay. So for the carbonate, thermal stability increases down the group. Why? Why? This is the structure for carbonate and this is a smaller metal cation. Okay. Let's suppose this is magnesium or this is lithium. They are smaller in size. When the smaller metal cation comes towards this oxygen negative, since it has a negative charge, so this metal can attract this oxygen, and as a result, this bond is going to break down. Technically, we can say the bond is polarized. When the size of cation is smaller, so it can polarize this bond easily. As a result, the bond can break easily. And carbon dioxide would release just like that. Metal oxide would be there. But when the size of metal cation is smaller, there is no need to provide extra energy to break down this bond. This is more than enough. It has a higher attraction. It has a stronger attraction. It can break down easily. You're not supposed to provide any type of energy. But when you have larger cation, like you have barium, of course, the size of barium is higher. So it cannot attract this oxygen easily. Why? Because the size of cation is larger. So then more energy, so then more energy, so then more energy needed to break down this bond. Extra energy is needed. Extra energy is needed to break down this bond. Why? Because the size of metal cation is not more than enough to attract this oxygen. That's the reason we have to provide extra energy. So when you have a bigger cation, when it approaches to carbonate, so due to larger size, metal cannot attract oxygen strongly. Therefore, this bond cannot polarize easily. As a result, it would not break down. So external heat is required to break it down. That's why when you go down the group, the thermal stability increases. The thermal stability increases. Why? Because the size of cation increases. 100% same explanation for the nitrate. 100%. But when you are going to break down this nitrate, so you will see these products. But when you are going to break the carbonates, you will see these products. That's the only difference. Explanation would be the same. You must include these points. You must include these points. Okay? You must include these points. Remember. So this is all about, and then you have to, then you need to know the solubility of hydroxides, solubility of hydroxide, and also the solubility of sulfate, solubility of hydroxide, and the solubility of sulfate. Okay. Since you go down the group, solubility of hydroxide increases. You have to only know the trend, not the reason. Only the trend. And what about the sulfate? Solubility decreases. Solubility decreases. Solubility decreases. Okay. And then of course you have some flame test. This is the thing that you have to memorize. So I'm skipping this one. Okay, sorry. And afterwards, we have a very baby chapter that you have also studied in your IGCSE, that is kinetics. That is what? That is kinetics. It's all about the rate. It's all about the rate. Of course, what is rate? What is rate? Change per unit time. What is rate? Change per unit time. Change per unit time. Change per unit time. Like change in concentration. Sometime it may be change in temperature. Sometime it may be change in volume. So change per unit time is called the rate. So what are the important things that you need to know? Factors. Factors. You need to know the factors. Like I mean to say that when concentration increases, when concentration increases, so the number of particle increases. When the number of particle increases, so of course the collision between the particle increases. When the collision between the particle increases, so of course when the collision between the particle increases, so rate of reaction would increase. Rate of reaction would increase, right? And then what about the temperature? And then what about the temperature? So remember, when the temperature increases, so the kinetic energy of the particle increases. When the kinetic energy of the particle increases, so means that, the rate of reaction would increase. Okay. And what about the pressure? When pressure increases, so the volume decreases, particle will come close to each other. Again, collision between the particle increases. Hence, the rate of reaction increases. Okay. And what's the difference between IG and this unit 2? Of course, there must be some difference. That's the main difference. Boltzmann distribution curve. You haven't studied in the previous chapters. So this is the new thing. Rest of the things you will do, like the concentration, like the temperature, like the pressure, like the blah, 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 volume. So basically the thing is that you need to relate with the collision. When the collision is higher, so the rate is higher. When the collision is lower, so the rate is lower. Simple. This is the normal temperature, white line. When the temperature increases, so the height of the curve decreases. It shifts towards the right. When the temperature decreases, so the height of the curve increases. It shifts towards the left. That's the important thing. What I have said? What I have said? When the temperature is higher, so the height of the curve is lower. This is your standard line. White line is your standard. So the height becomes lower and it shifts towards the right when the temperature is lower. So the height of the curve is higher and it shifts towards the left. Okay. There would be no effect on activation energy. There would be no effect on activation energy, remember. Okay. If they are going to add a catalyst, if they are going to add a catalyst, yep, then the activation energy would decrease. Okay. This is without catalyst and this is with catalyst. Like, of course, what is the definition of catalyst? It increases the rate, it lowers the activation energy, and it provides alternative pathway. That's it. It provides alternative pathway. So you need to focus on Boltzmann distribution curve. Rest of the things are the same, 100%. Rest of the things are 100% same. Okay. Okay. And then the very important chapter, equilibrium. Left right, forward backward, forward backward, forward backward. So let's suppose he would be asking, I'm going to increase the concentration of A, but before going to do this, always remember my point. Always the things move from higher potential to the lower potential. When you are going to increase the concentration of A, so your reactant becomes at a higher potential. So higher to lower. It shifts towards the right. It shifts towards the right, left to right. You know why? Because you have increased the concentration of A from higher to lower, always fixed from higher to lower. What if I'm going to increase the concentration of D? Of course, then your product side would be at a higher potential. So it would shift towards the left. Left, higher to lower, higher to, I'm going to decrease B. So your reactant would be at a lower potential. So the the reaction would shift towards the left, always from higher to lower. That's the key point. That's the main point. Okay. Hopefully you understood this. And what about pressure? The term pressure is only applied on the gases. There are three cases. Case number one, more reactant, less like when you have the same number of moles, 3 moles of reactant, 3 moles of product. So when you are going to increase or decrease the pressure, there is no change. There is no change. There is no change. Okay. There is no change. So no change means that the reaction will not shift towards the right. The reaction will not shift towards the left. Okay. So, and then case two, what if you have 4 moles of reactant and 3 moles of product, like more moles of reactant and less moles of product? Of course, the moles of reactant is higher. So when you are going to increase the pressure, so the reaction will shift towards the right, higher to the lower, higher to the lower, higher to the lower. Okay, that's it. And what if you have more moles of product, less moles of reactant? So when you are going to increase the pressure, shifts towards the left, shifts towards the left. I told you, always from higher to lower, always from higher to lower. That's the concept and that's the key point. Okay. That's the key point, right? Okay. And what about the temperature? It depends on the type of reaction. If you have exothermic reaction, and when you are going to increase the temperature, so the reaction will shift towards the left. And if you have an endothermic system, and in an endothermic, you are going to increase the temperature, so the reaction will move to the right, forward direction, forward direction. Okay. And if you are going to add a catalyst, if you are going to add a catalyst, so catalyst has no effect on equilibrium. The job of a catalyst is to only change the rate. The job of a catalyst is to only change the rate, not the position of equilibrium. Not the position of equilibrium, not the position of equilibrium, remember. Okay, so that's the key point. And and you must know what is homogeneous system and heterogeneous system. Listen very carefully. Homogeneous and heterogeneous. So if you remember, we had Haber process, we had Haber process, and we had contact process. We had contact process. What was the Haber process? Nitrogen was reacting with hydrogen. It was producing ammonia. And sulfur dioxide were reacting with oxygen. It were producing SO3. It was producing SO3. Okay. What was the catalyst? Iron. What was the catalyst? V2O5. Solid. Solid. Gas, 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 gas. So since the reactants are gases, since the reactants are gases, but the catalyst is solid, but the catalyst is solid. This is called heterogeneous system. Are you getting my point? This is called heterogeneous system. How can you identify in your exam? Examiner would be giving you all the things. Otherwise, you will not be able to identify whether the system is hetero or a homo. Of course, you cannot identify until or unless the examiner has given you the full and fledged information. So just like that, I had told you that iron is catalyst and iron is solid and the substances are gases. So the reaction is heterogeneous. So can you give me an example of homo? Yes, if you remember in IGCSE you used to form ester. You used to form ester. Ester is formed by the reaction of alcohol and carboxylic acid. Carboxylic acid was aqueous. Alcohol was aqueous. What was the catalyst? Sulfuric acid. That was also aqueous. Aqueous, aqueous, aqueous. This was homogeneous catalyst. This was homogeneous system. Are you getting my point? For hetero, for hetero, different phases. Solid gas, solid liquid, liquid aqueous. And when you can see homo, same phase. When the reactants are aqueous, so the catalyst should be aqueous. When the reactants are gases, so the catalyst should be gas. When the reactants are solid, so the catalyst should be solid. Like the same. When you can see the same, when you can see the same, so that would be homo. And when you can see the different, so you can say that the system is hetero. That's the difference. Okay. And afterwards, then we have then we have organic chemistry starting from but before starting you need to know some basic things like what is nucleophile, what is addition reaction, what is elimination reaction, substitution, oxidation, reduction, hydrolysis. So how can I say whether the reaction is addition or not? For addition reaction, only one product is formed. Only one product is formed, remember. And for substitution, you can see more than one product. Let's start from this chapter, that is halogenoalkane. Halo means salt, group 7 elements. Alkane. When alkane is connected with any of the halogen, it would be known as halogenoalkane. Haloalkane. The general formula is this. It would be sometime fruitful for you when you would be asking in MCQ, of course, CnH2n plus 1x. Nothing is nothing is worthless, remember. You must know the importance of each and every small thing, okay? To get a good grade. So we have some family members, methyl chloride, ethyl chloride, propyl chloride, butyl chloride. And the bond is polar, of course. The bond is polar. Why? Because this is highly electronegative. It's going to gain electron. It would become partial negative. This is R group. It would become partial positive. Okay. To become a polar one, you must have different elements with different electronegativities. I'm repeating. To become polar, you must have different elements with different electronegativities. Okay. To become polar, you must have different elements with different electronegativities, just like RCl, RBr, RF, Ri. You may have any of the halogen that would be polar. But of course, some molecules are more polar, some molecules are less polar. It depends upon the value for the electronegativity. Interestingly, the value would be given to you in your exam. I'm talking about the value of electronegativity. It would be already given to you. Okay, that can easy for you. So so you can decide whether the molecule is more or less polar. And then physical properties. Uh, Physical property. Let's talk about the boiling and melting point. They are having high melting and boiling point as compared to normal alkanes. Because normal hydrocarbons are having London force and they are having permanent dipole. How? They are polar. If they are polar, so they will have permanent dipole PD. P for polar, P for permanent, P for polar, P for permanent dipole. That's why they are having high boiling point. Okay, and same goes the same concept that I have told you. As the number of carbon increases, as the number of carbon increases, so the melting and boiling point increases. You know why? Because the intermolecular force increases. Okay, because the intermolecular force increases, and you can see that when the surface area increases, again intermolecular force increases, so the melting and boiling point would increase. Okay. Yeah, polarity decreases. Why? Electronegativity decreases. As I told you, depends upon the value for electronegativity. Okay. And you can see strength of bond is inversely proportional to the bond length. You cannot break down this bond easily, but you can break down this bond easily. Why? Because the size of iodine is larger, so of course the bond length would be higher. When the bond length would be higher, so less energy would be required to break down this bond. That's the reason there are less amount of energy needed to break down the Ci bond. Okay. So I have drawn some diagrams to make it more easier how I can say that the bond is broken down easily since the size is larger, so nuclei are far away from each other, and of course there would be less energy needed to melt or boil this substance. Okay. And what about the solubility? Interestingly, they are polar, but they are having partial solubility, smaller solubility. It's quite interesting. Generally, we say when the substance is polar, it would be having higher solubility. So why this is so for the halogenoalkane? The thing is that whenever we add anything to the water, like let's talk about sodium chloride, when it goes to the water, it breaks down into the ions, isn't it? Am I right? So same goes with this one. When you are going to add this in water, it may be, you can say that it can also break down into these ions, positive and negative ions, but they will not break down. You know why? Because the bond is very stronger. The bond is very stronger. They cannot break down into the ions very easily. If you have 100 molecules of halogenoalkane, like methyl chloride, out of 100, out of 100, only 10 molecules will be breaking down into the positive and negative ions. That's why we can say they have a lower solubility in water. Okay. After adding halogenoalkane into water, the new bonds between water and halogenoalkane are going to be formed, but old attraction needs to break down. Of course, I'm talking about this one. Due to strong attraction, breaking of bond is not possible. Hence, halogenoalkanes are slightly soluble in water. Hence, halogenoalkanes are slightly soluble in water. Okay, but they would be soluble in organic solvent. Remember, they have a lower solubility in water, but they have a higher solubility in organic solvent. Okay, so you can prepare halogenoalkane by alcohol if you have these three things: PCl3, PCl5, and SOCl2. These are very important reactions. Your life become easier if you are going to memorize before your exam. These are inorganic products. This is your organic product. These are, let me mention this, inorganic product, and this is your organic product. I have seen in some questions that examiners ask to write down only the inorganic product. So you need to know which one is organic product and which one is inorganic product. Okay. Nucleus loving. Nucleophile is nucleus loving. Substance which can donate a pair of electrons. It's not mandatory that the nucleophile have a negative charge. No, nucleophile can be neutral. Nucleophiles can be neutral. They can be negative, but they cannot be positive. Remember, okay? Ammonia. What's the charge on ammonia? You will say, sir, there is no charge, but this is nucleophile. Why? Ammonia. Nitrogen is having one lone pair of electrons, so it's called like it can act as a nucleophile. Water has no charge, but water is a nucleophile. Why? If you are going to draw the dot and cross diagram for water, you will see there is a lone pair on oxygen. Water is nucleophile. So it's not mandatory that nucleophile is always going to have a negative charge. No. There are two types of nucleophile, neutral and negative. Nucleophile cannot have a positive charge. Okay. These are some examples. Then we have three types of halogenoalkane: primary, secondary, and tertiary. Okay. Specifically, we would be looking at these reactions: hydrolysis, formation of amine, and formation of nitrile. SN reaction, nucleophilic substitution reaction, SN reaction. Okay. First of all, we have SN1 reaction. First of all, we have SN1 reaction. SN1 reaction means that it can occur in two step, but in this unit you are not supposed to look at these things, okay, which one will occur in one step and which one will occur in two step. No, it's not mandatory for you. Okay, just you have to see, is there any nucleophilic substitution or not? That's it. Like, let's suppose, if you can see this, uh, you have halogenoalkane. Okay, I'm going to react it with ammonia and heat under reflux. So ammonia can replace this Cl with NH2, and HCl would be eliminated from this reaction. It's called nucleophilic substitution. This is a nucleophile. This is a nucleophile. Nucleophile is going to displace the nucleophile. So this is called nucleophilic substitution reaction. It's a substitution reaction. Okay. And again, ammonia in ethanol. I have this reactant. Again, I would see the same product. So NH3 can substitute this Cl. You know why? Because ammonia is a strong nucleophile as compared to Cl. As compared to Cl. If you are thinking in your mind, sir, what if I have ammonia aqueous? Why you are taken in ethanol, isn't it? If we have ammonia aqueous, then what would be the product? So chlorine would be substituted by OH. Alcohol would be produced, but I don't need alcohol. I need this one. So you need to take ammonia in ethanol. That's the key point. Okay. See this aqueous. So alcohol is produced. Aqueous. Alcohol is, oh my God, no. Concentrated ammonia. It's not simple ammonia. It's concentrated ammonia. Whether you are going to take in ethanol, whether you are going to take concentrated, they would give you the same product. They would give you the same product. Okay. And what about this one? If you need this one, nitrile, so you need to react your reactant with nitrile. Nitrile comes from NaCN and KCN in ethanol, heat under reflux. So Cl would be substituted by the nitrile. You can have this product. It's quite simple. Okay. And if you are going to hydrolyze your nitrile, we have two types of hydrolysis. We have two types of hydrolysis. Acidic hydrolysis of nitrile give you carboxylic acid. Basic hydrolysis of nitrile will give you the salt of this acid. It's quite simple. It's quite simple. Okay. Acidic hydrolysis will be giving you carboxylic acid, and basic hydrolysis of nitrile will give you the salt of that carboxylic acid. That's the main point. That's the key point. Okay. And what if I need to prepare alcohol from this halogenoalkane? So, sir, should I react with KOH? Yes, you can react because we need OH. Because we need OH, whether it's coming from ammonia aqueous, whether it's coming from potassium hydroxide aqueous, we need OH. We need OH, remember. Are you getting my point? And I'm giving you this equation. Just look at this. We have elimination reaction. What is this? What is this? This is halogenoalkane, and I'm going to react it with sodium hydroxide in ethanol. So, sodium can react with this Cl. Sodium chloride would produce. OH can react with this H. Water will produce. And alkene is produced. Alkene is produced. Okay, this is called elimination reaction. So you must have beta hydrogen. You must have beta hydrogen. You know why I'm saying this? Look at this. Look at this. Why I'm saying this? Look at this. See this one. You will come to know why I'm saying this. Yes. What would be the product? There is no reaction. What would be the product? There is no reaction. You know why? Why there is no reaction? Because there is no beta hydrogen. Like this is Br. This carbon must have hydrogen. This carbon must have hydrogen, but there is no hydrogen. So elimination reaction is not possible. Okay. Are you getting my point? So you have to see whether the elimination reaction can take place or no. If you have a beta hydrogen, if you have a beta hydrogen, So then elimination is possible. But if you don't have beta hydrogen, so elimination reaction is not possible. Is not possible. Okay, that's the main point that I want to show you. Okay, is that clear? So this is about elimination reaction. Sometimes it's possible, sometimes it's not possible. Okay, and then we have alcohols. Like of course, alcohol means that they have OH functional group. Okay, they have OH functional group just like that. So the general formula is CnH2n plus 1 OH. And again, again, we have three types of alcohols: primary, secondary, and tertiary, just like halogenoalkane. Okay, this is primary 1 degree, this is secondary, this is tertiary. Physical properties: liquids at room temperature, they are polar, they are having high melting and boiling point as compared to halogenoalkane. You know why? They have hydrogen bond. They have hydrogen bond. Okay. Same explanation for the intermolecular force. As the number of carbon increases, blah blah blah. That they are the same thing. Alcohols are slightly acidic in nature. They give H positive ion. When you will determine the pH of the solution of alcohol, you will see the pH would be less than 7. Slightly acidic, not too much acidic. Okay. And you can prepare alcohol. If you are going to have alkene, you are supposed to add water. This is called hydration at these conditions. So you will have alcohol. You will have alcohol. You can do combustion reaction as well. Okay. Alcohol can be combusted very easily. They would be producing carbon dioxide and water. Again, the same thing. And you can produce alcohol by the reduction of your aldehyde. This is very easy. You can produce alcohol. You can produce alcohol reduction of aldehyde. This would be the reducing agent, that is LiLH4 in dry ether. These are two reducing agents. And if you have ketone, so you can reduce your ketone into the secondary alcohol. This was primary alcohol, and this is secondary alcohol. Ketones can be reduced into secondary alcohol, and aldehyde can be reduced into the primary alcohol. This is combustion reaction. So you need to memorize all the reactions, all the reagents, all the conditions. Okay. You can dehydrate alcohol, of course. This is also known as elimination reaction. Like sulfuric acid is a dehydrating agent. If you have this alcohol, again, this is called alpha hydrogen, this is called beta hydrogen. So you can remove water. OH is removed from this carbon and hydrogen is removed from this carbon. You can see the double bond over there. Okay. Or you can remove this OH and this H. So you can see the double bond over there. This is called the removal of water. So who has removed this water? This was the dehydrating agent, sulfuric acid concentrated. Again, if you have ethanol, so you can make ethene by dehydrating carbon dioxide and sulfur dioxide would be the inorganic products. Okay. Again, you can dehydrate these. Sometime you can see the double bond over there. Sometimes you can see the double bond, but you must have beta hydrogen. Okay. Yeah, you can see that. Not possible. Why? This is OH, but where is hydrogen? This is carbon, carbon, carbon. There is no beta hydrogen, of course. The dehydration is not possible. The dehydration is not possible. Okay. And alcohols are acidic in nature, so they can react with reactive metals only, sodium, potassium from group 1 especially, because they are more reactive, and they can produce salt and hydrogen gas. Salt and hydrogen gas. Okay. Alcohols can be oxidized easily. Like you can see, we have oxidizing agent, that is KMNO4 and also the K2Cr2O7. If you have a primary alcohol, so it can be oxidized into aldehyde, and furthermore it can be oxidized into carboxylic acid. But if you are going to use this condition, heat and distilled, so only alcohol will convert into aldehyde. That's it. And if you have heat under reflux, so primary alcohol will change into carboxylic acid. That's the key point. Heat and distilled, the product is aldehyde. Heat under reflux, the product is carboxylic acid. If you have secondary alcohol, that can oxidize into ketone. Ketone cannot further oxidize. And if you have tertiary alcohol cannot oxidize further. Tertiary alcohols cannot be oxidized further, remember. Okay. And I need to have this one, but I'm going to give you alcohol. So you can react with PCl5. Simple. OH will be displaced by this chlorine. So you will have halogenoalkane. Simple. HCl, you can see steamy white fumes due to HCl. And what if I need this one? So this would be the reagent. OH can be replaced by this iodine. This is the condition red phosphorus. So you will be having this one. If you need this one, so this is the condition. All the things you need to memorize, trust me. If you have a good grip on these memorization, you will ace it. You will ace it, okay? And you can see the past paper. And if you are feeling that I'm not able to do that past paper, what he is asking specifically in that exam, in that question, so if you are not able to do this one, so you can send me on WhatsApp. I would be helping you out, inshallah. Or I think so, according to your specification, you have then mass spectra and IR. Or these are the techniques, of course. This is the game of data booklet. You know at what wavelength or wave number you can see the peak. I'm talking about infrared spectroscopy. And also the same goes with the mass spectrometry, okay? So you can see few questions related to this one. But first focus on organic chemistry. Then the second number is inorganic chemistry. I'm talking about group chemistry, especially group 1 and group 2, especially the trends. Especially the trends, okay? So that's it. Okay. And you have to do 2025 paper. I have recorded the session. I'm going to share it with you as well. I'm going to upload it on YouTube. So you can see over there. And if you feel that you are not able to do any of the question, then I'm here. You can tell me. Okay.